You might come across this in your next exam. Here's exactly how to go about it. The number of hydrogen ion in 4.9 grams of tetraoxosulfate 6 acid is now the first thing we need to note is that you are asked here for the number of hydrogen ion. So dissociation must have happened, which becomes H2SO4. If this dissociates, you'd get hydrogen ion plus SO4 2 minus SO4 2 minus would get this. And going further, we'll try to balance this. We'll just need to include 2 here, and this is actually it's balanced. It becomes balanced. Next thing to do is that we write out like the ratio of mole between tetraoxosulfate 6 acid and hydrogen ion. That becomes here we have 1 mole, right? So 1 mole here. Here we have 2 moles. Once this is done and established, the next thing to do is we would solve for the mole. Since we are given 4.9 grams, we are given tetraoxosulfate 6 in mass. We'll solve for its moles. And how do we go about that? We'd say we'll first calculate for its molar mass. And so H2SO4 has a molar mass of, let me calculate it, 2 times 1 bracket plus 32, which is our sulfur, plus 4, this 4 here, times the atomic mass of oxygen is actually 16. You can see it from here, 16. So 16. And our total value will be 98. Next, making use of our mass from our equation here. Our mass is given to be 4.9 grams. You see, 4.9 grams. So solve for mole. So mole equals mass, which is mass over molar mass. And mass is 4.9, molar mass is 98. If you divide this, we get 0.05 mole. 0.05 mole. Once this is also established, the next thing to do now, we'll solve for the number of ions, which is what we are asked to solve for. But we need to first compare this before we solve for the number of ions. So from our equation here, we are having 1 mole. From here, we have 1 mole of H2SO4 and 2 moles of hydrogen ion. And from the data given, we're able to get 0.05 mole. So what you would do now, the next thing you do, you make use of this 0.05 mole. You say 0.05 times this here times 2. So times 2, and this would give us 0.1, right? I'll quickly punch that here. So 0.05 times 2, 0.1, correct? This 0.1 that was given now becomes the mole of the hydrogen ion. So mole of hydrogen ion. And lastly, if you recall, the formula to calculate for number of ion is actually ion is equals mole times Avogadro's constant, AVC. So lastly, we say number of ion would be the mole that was given is 0.1 times the Avogadro's constant that was given is 6.02 to the power of 23 times 10 to the power of 23. So point is 0.1 times 6.02 exponential 23 exponential 23, and you get 6.02 times 10 to the power of 22, and this is your final answer. So let's go back and check if any of our option tallies. And yes, there we have it. Option B tallies with our answer. So the correct answer is option B. Would you like to practice similar questions? Click on the link in the description box. You win. Just believe this.